Hello, everybody, and welcome back to our math class. Today, we are going to be talking about heights, and we are going to prove that heights are angle bisectors in the orthic triangle. So let's start by looking at a triangle ABC. So there you go. Here's ABC. This is vertex A. This is vertex B. This is vertex C. And let's look at the heights of it. So this is AD. Point D right here, and we've got a right angle. Here's BE. Point E right here, and we've got another right angle. And here's CF. Point F right here, and we've got another right angle. Well, the presence of these right angles leads to a wealth of angles that either we can express in terms of the angles of the triangle ABC, or angles that are related to each other. So look at what's happening here. Let's look at this angle AFC. So the angle AFC is 90 degrees, no? And it's equal to the angle in D here, ADC. Well, what does this mean? This means that quadrilateral AFDC is cyclic, no? Let me highlight the quadrilateral here. So AFDC is a cyclic quadrilateral. And why is that? Because the angle determined by one side of it with one diagonal is equal to the angle determined by the opposite side with the other diagonal. So that quadrilateral is cyclic. And then what can we conclude further? Well, let me connect F with D here. Well, what follows actually, for example, is the fact that angle A plus angle FDC is 180 degrees. So it means that I'm just going to say A as the angle in triangle ABC plus the angle FDC is 180 degrees. Let me highlight the angle FDC one more time so we see it. All right, so this angle right here plus angle A is 180 degrees. But then what else is going on here? Well, the angle FDC plus the angle FDB is 180 degrees. So FDC plus FDB is 180 degrees, which means that our angle A is equal to our angle FDB now. So A is congruent to the angle FDB. And also, if we actually connect D with E, we will be able to prove in virtually an identical fashion to the way we prove that angle A is congruent to the angle FDB. So FDB is right here, A is right here, and they will be also congruent to the angle EDC now. Okay, again, this is a little homework for you. So we will conclude further by virtually an identical argument that the angle FDB is congruent to the angle EDC and with angle A, no? Well, but now the problem is actually solved because look at what's happening here. If we look at the angle ADB, there you go, I'm highlighting the angle ADB. And if you look at the angle ADC, these two angles are both 90 degrees now. And we've got these parts of them being equal to each other. So what that implies is the fact that the complements of them, no? So the angle FDA being complement to angle BDF is congruent to the angle ADE, which is complement of the angle EDC, no? So that means that AD is angle bisector of angle FDE. All right? So we've got an angle bisector here, and virtually through an identical process, we will show that, for example, these two angles are congruent to each other, and also these two angles are congruent to each other. So heights of the triangle ABC are angle bisectors of the orthic triangle. All right. So thank you very much, and please fill in the details of our claim that the other two angle bisectors are of angle FED, for example, and DFE are heights in triangle ABC. Thank you very much.